Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Carl Carlson.
And this is Dianna. Hi, Carl.
Hi, Dianna. So I've got a potential topic for us to talk about. I've been writing about it and thinking about it. And in fact, in our email exchange where we leading up to this, you were mentioning some of the strengths and weaknesses of FMEA. And there's one of them that came to mind that I would consider probably the least understood and potentially the most powerful of the data elements in an FMEA.
Mm-hmm.
And it's the use of special characteristics in an FMEA. So I just thought that'd be fun to talk about. What do you think?
I think so, because it goes by many different names.
Yes, it does.
When we were preparing for this episode, you were calling it special product characteristics. And I said, I think I know what you're talking about, but explain it. And then I recognize it as essential design inputs and critical quality attributes. So there's just a whole slew of names for this very important aspect of FMEA.
Yeah, so let's actually get to the definitions first, because in an FMEA, you have, let me actually open up something, make sure I get the definitions right. So let me just start with characteristic. Characteristic is a feature or quality belonging typically to a thing or an item that you're analyzing. And that's important to know because everything that we analyze in reliability and FMEA has characteristics. There's lots of different characteristics. And they can be broken down into product characteristics, which are, of course, the attributes or properties of a part, like color, weight, surface finish, et cetera, material composition, or in dimensional, or they can be process characteristics, which are, and I go back to Duran, and he basically initiated a lot of this discussion about product and process characteristics because he understood how important it was to control the product characteristics and the process characteristics. So a process characteristic, if you get to the understanding the manufacturing process, it's attributes of the manufacturing process. And that is very critical when you're doing a process FMEA, and it's critical when you get to process control plans. So let me just take that up for a second and get a process characteristic. It can be process variables or parameters. They typically have a cause and effect relationship. They're tied into the variation that are found in product characteristics. So you have like cycle time or pressure, flow rate. It could be things like tool speed, mold temperature for molds, and things that are basically attributes of the manufacturing process. So in the latest standards, we've done a lot of work to introduce product characteristics into FMEA and make sure they are identified data elements in the FMEA itself, and then linking them to the process characteristics and making them part of the process FMEA and the data elements in the process FMEA. So that's kind of a long introduction, but I wonder what your experience is on these type of characteristics, whatever we call them, whether you call them critical, special, key, there's all these different languages.
Yeah.
What's been your experience with it?
Well, from Design FMEA, we would normally plan this ahead of time in deciding if something is severe enough or has high enough of occurrence, or there could even be a threshold for detection too. But if something from the Design FMEA was identified as an essential design output, what we would do is we would make sure that we would have controls, extra controls, or focus our efforts on developing controls for those things. And that might be communicating to the supplier. If we have a technical drawing, they would be identified as critical. And we would tie that to validation and verification to make sure that those things were tested. And I guess it's the same kind of treatment in the process FMEA, where, like you said, those special characteristics that can have an impact on product quality were identified. They could be identified in the process document itself to the operators. They could have extra controls on them. They could be things that the quality control people would inspect for. And so these were all things that I guess sometimes these things can be defined by the engineers, the product engineers or the process engineers based on their experience. But an FMEA is another approachable way to do it with a team, adding their experience, but then also looking at the overall effect of what that failure could have on what's intended. So it could be an extra source of identifying those essential characteristics. The FMEAs could be an extra source.
Excellent, excellent. And I agree with that completely, because the whole process or system in a company to identify special characteristics or critical, sometimes called CQIs, critical to quality index, whatever you call it, they have a process to identify those. And that process doesn't always go through FMEA. You can identify special characteristics by the engineering team, or because they've always been that way. You have engineering judgment, and the FMEA can identify, I'll call them candidate special characteristics. So when I go to the recommended actions, if we want to make something a special characteristic that isn't, the FMEA team doesn't deem it automatically. They basically say this is a candidate, and it goes then to the special characteristic team to confirm. So I just want to throw that in there.
Yeah, I like that approach.
Yeah. Let me give an example. First time I ran into this, I was a young engineer, fresh out of college, and I had a job. I was supervising in a test lab. This was on doors, so car doors, and of course, car doors went through all the testing. We'd open them and close them, and we'd run the windows up and down, things like that. Inside the car door was it's called a door impact beam, basically a solid beam that if you get side swiped, hopefully it prevents the door from crushing into the compartment. And this is before airbags and that kind of thing. And true story, we would test statistically significant testing on all the door impact beams.
Okay.
And that, so you get a new type of car, a new whatever, they make a certain number of door impact beams, and then we'd put them on a test device, and then we'd do force deflection curves to make sure they were strong enough.
Okay.
And we thought about that after a few years of doing that. We go, I wonder if we controlled the diameter of the beam and controlled the material composition of the beam, whether we could calculate the force deflection. So we went about in parallel and controlled right in the drawings, right in the blueprints. I'm dating myself. And you have this impact beam that has a certain diameter, certain material composition that's specified. And if it meets those specifications, that's input to our analysis. But we would then calculate the deflection. At the same time, we would test it. And we did that for months and months and months. And it turned out to correlate beautifully. So at that point, we no longer needed to do as much physical testing. We basically modeled the force deflection using the special product characteristics. Back then, we called it KPC, key product characteristics, as the diameter of the beam and the material composition. And then the manufacturing process for the supplier of the door impact beams, they would have to hold those very tightly according to the process control plan because they were special characteristics. That worked beautifully. It saved a lot of money from, and that was my first run-in. And then I thought about something, Diana, which is how does the FMEA interact? So if the FMEAs being done on a door impact beam by the supplier, it has a function. It has to be, it has to maintain integrity, not deflect under stress.
Yes.
That specification, that degree of allowed deflection, which is very small, but it's a certain amount allowed, becomes a requirement. And then if it bends or it breaks, that becomes a failure mode. And then the cause is going to be some potential design deficiency, such as the diameter is too small, or such as the material composition is wrong. It's like not hard enough, or whatever the metric is. Those then became input to a column we added years ago called special product characteristic. And that column was derived from the cause. If we had a proper cause statement, which was the potential design deficiency, then that was input to the description of the special product characteristic. So I just wanted to share that story with you and how it ended up in FMEA literature. It then ended up in the AIAG and the VDA standards, and it's going to end up in the new standard that's replaced in 1629 and many other standards called special product characteristic and special process characteristic. So I wanted to introduce that and let people know that the properly worded cause can be a huge aid in identifying special product and process characteristics. And then let me hear your thoughts and anything you want to add to that. And then I had a final comment, so to speak.
Yeah, I think that's one of the important things that come out of FMEA. You mentioned earlier, like all the different data categories and data points that you can use for FMEA. It's not just an RPM. And this is one of those important things that you can learn. The other thing that's a benefit with FMEA when you're identifying these special characteristics or critical quality characteristics is that when you're generating these FMEAs, that the table is really just an output to a team exercise. And it's the experiences and the varying backgrounds of the people on your team that are helping you to work through some of these failure ideas to identify what are the key quality attributes or what are these special characteristics. Sometimes you'd be surprised that there were designs that were similar enough, but had a slightly different application. And in the end, there was a key special characteristic that was in one, but it didn't necessarily impact the other one. So just assuming that it's key here doesn't necessarily mean it's key there. And FMEA is a way that you can discern that. Because to focus on these critical characteristics and it requires a special focus. So it's effort, it's time, it's money to do the testing, and it's ongoing quality checks. And you don't want to just do it on everything. You want to be able to identify what's important and what's going to have an impact. So that's another way, not just to maintain the quality of your product, but also to prioritize what's important.
I agree with you completely. One of the lessons learned when we first introduced special characteristics in the automotive industry was the design engineers, if we left it to them, they made their characteristics special. And what ended up is that nearly everything became special.
Yeah.
when you added it all up in the automobile, and then it became like junk mail. The plant became overwhelmed, and nothing got tracked the way it should. So a key aspect of this whole process is to get the vital few. And you brought it up when that's absolutely correct. We don't want to make everything special because we're highlighting those with extra testing. Everything gets due care,
Right.
but certain things get extra care. And those we designate critical or key or special, and they have to be the vital few. So we got to use the Pareto principle and narrow down to the vital few. So when you control those, you get the outcome you want. And the danger is to make too many things special or critical. So I just wanted to concur with you on that.
Yeah. And it's along the lines of FMEA can give you that stepwise process to be able to evaluate things, so that you're not feeling the pressure that if I design this and I put this tolerance, if I'm, adding a tolerance, how tight do I need to make this tolerance? Do I need to make it really tight? Or is it not as critical? So doing this activity also sort of leads into design for manufacturability, because like you said, you're identifying the vital few, and the FMEA can be a process, a way to work out what those vital few are with a team of people. So it's not completely resting on your decision making at the time that you're creating a drawing or you're defining the spec. There's a process behind it, and it's related to risk. And there's some I wouldn't say that there's comfort in that, but it takes I guess it's a more well-rounded approach to doing it than shooting from the hip.
Absolutely. And another input from FMEA, cause helps you get the description. What triggers the process is often severity, sometimes occurrence. So different companies have severity, occurrence guidelines for what triggers a special characteristic designation. And so on a scale of 1 to 5, maybe all the 5s would be, or the 4s and 5s, if the 4s have a certain occurrence. It's totally up to the company to do that. But the FMEA ratings for severity and occurrence can be input to that designation system, but I wouldn't just leave it to the FMEA team. I would encourage the company to adopt their selection criteria to designate something as critical. Since, as you point out, it's not just the FMEA that creates special product characteristics. So you want to have a process outside of the FMEA, but severity and occurrence can be input to that.
Yeah.
So this is I would like to see more use of special characteristics in FMEA and reliability. Like I worked with a company years back, and we were allocating reliability, which is not one of my favorite techniques, and I can explain that in any time. But because it's been misused for so many years, reliability allocation, but they were allocating reliability, and I said, well, you don't just want to get down to the piece part and say it's a 0.999 reliability. Why don't we take it a step further and get the special characteristics on those parts that relate to material, relate to dimensions, that relate to all the other ways you can describe characteristics. And so we ended up with a reliability allocation and specifications that didn't just result in a reliability number, but also resulted in the special characteristics that had to be controlled. So it added a little more value to the subject of reliability allocation.
Did you use FMEA to help figure out what those characteristics were, or?
Absolutely did.
Mm-hmm.
So we would use and this is one of the places that it became apparent to me, I mean, a number of places it became apparent that the cause is a huge input to the description of which characteristics become special. Because if you have a cause that relates to a high severity, I want to pay particular attention to get that cause converted into potential or a candidate special characteristic, so that we can be sure that that high severity doesn't happen. So yeah, it was interesting how it all relates between reliability, characteristics, and FMEA, how they relate together. There's some principles that are so important. I'm wondering if our listeners have, if we could do a poll, if we were like interactive, I would do this as a poll. I'd love to hear from people as to whether you're using special characteristics as part of your FMEA. Is your FMEA informing your special characteristics? Do you even have a special characteristic designation system in your company? So I'd just love to hear from you if you'd care to let us know. And also on anything else, things you'd like us to podcast on. We're always looking for subjects.
And you can leave your feedback and your questions and, I don't know, give Carl and I some input on what you're doing at your own company and how your company is handling these things. And at what level do you feel like it's good enough, or do you wish you did it a little bit better? You can leave this kind of feedback at ascendo-reliability/go/SOR. Carl and I and the other members of the Ascendo Reliability team are available. You can reach us at Ascendo Reliability, and Carl and I are also on LinkedIn. Well, Carl, it's been nice talking with you.
Yeah, I love these kind of podcasts, Dianna, where we're exploring topics and actually getting each other's viewpoints and coming up with new ideas. That makes it a lot of fun.
Yeah, and especially with our different experiences, it does make it fun and interesting. So I appreciated talking with you. Hope to do it again soon.
Talk to you soon. Bye-bye.
Bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.